Assalamu alaikum. Lecture 2 Gas Laws. The properties of gases. We can predict the behavior of gases based on the following properties: pressure, volume, amount, and temperature. We talked about all of these parameters in the previous lecture and we gave the units of each of them. The gas laws consist of Boyle's law, Carnot's law, Kirosak's law, and Avogadro's law. Boyle's law describes the relationship between pressure and volume of gases at constant temperature. The pressure of a fixed amount of gas varies inversely with its volume. That means the volume of the gas increases as the pressure decreases. If you squeeze a gas sample, you make its volume smaller. Now a container where the volume can change, a syringe. So syringe A contain a volume of 100 milliliter at 25 centigrade, and when we move the piston, we make the volume 50 milliliter at the same temperature. We can observe that the volume of B will be the half of the volume of A. So in which system is the pressure higher? Of course, it will be B because the volume decreases, the pressure increases. A fixed amount of gas occupies a volume of 1 liter and exits a pressure of 400 kilopascal in the walls of its container. What would be the pressure exerted by the gas if it is completely transferred into a new container having a volume of 3 liter, assuming the temperature and quantity of gas remain constant? So if we want to solve this problem, we have to identify the given information and what the problem is. So the given information is the initial volume V1 equal 1 liter, the initial pressure P1 equal 400 kilopascal, and the final volume equal 3 liter. What we have to find, we have to find the final pressure, and then we have to plan the problem. So Boyle's law, P1 V1 equal P2 V2, and then we have to rearrange the equation P2 equal P1 V1 divided by V2. And now we have to substitute the known information, the initial volume 1 liter, the initial pressure 400 kilopascal divided by final volume 3 liter, and we have to calculate the result. 133.33 kilopascal. Now we have to think about our results. The initial pressure 400 and the final pressure 133. That means the pressure decreases, and of course the volume increases from 1 liter to 3 liter. Carnot's law. Carnot's law describes the relationship between the volume and the temperature at constant pressure, and the volume of the gas increases as the temperature of the gas increases. And the equation of Carnot's law, V1 divided by T1 equal V2 divided by T2, and includes increase the average kinetic energy and increase the speed of the particles, and the walls of a flexible container expand For example, think about a hot air in a balance. If we want to take an example to explain the Carnot law, we take a steel cylinder of 2 liters, contains 500 molecules of oxygen at 400 Kelvin, and we can increase the temperature to 800 Kelvin to the same volume and the same molecules of oxygen. Now we have to think in which system do the oxygen molecules have the highest average kinetic energy. As we take in the previous slide, it will be B because the temperature in B more than the temperature in A. In which system will the particle collide with the container walls with the greater forces? So which one is a greater force? Of course, it will be B because the temperature in B again higher than the temperature in A. And in which system is the pressure higher? Again, it's B because the temperature is more than A. For example, a balloon is filled to a volume of 2.2 liter at a temperature of 22 centigrade. The balloon is then heated to a temperature of 71 centigrade. Find the new volume of the balloon. Again, we have to identify the given information and what the problem is. So for the given information, the initial volume 2.2 liter and the initial temperature 22 centigrade. And here we have to convert the temperature to the Kelvin by adding the 22 with 273. That's equal 295, and the final temperature 71 adding 273 equal 344 Kelvin. And what we have to find? We have to find the final volume. So we have to plan the problem and rearrange the equation to find the final volume. V2 equal V1 times T2 divided by T1. And now we have to substitute the known quantities into the equation and solve. And we have to cancel the unit and we have to calculate our result, which is 2.57 liter. And now we have to think about our result. So the initial volume 2.2 and the final volume 2.57. That means the volume increase from 2.2 to 2.7. And that mean is the temperature increases as well from 295 to 344. That's what Carnot's law says. Ghirasak's law. Ghirasak's law say that the pressure and absolute temperature of a gas are directly related at a constant mass and volume. And that means P1 divided by T1 equal P2 divided by T2. And that means the relationship between the pressure and the temperature. In a closed container, ideal gases initially have a temperature of 27 centigrade. If the final pressure became 2 times the initial pressure, what is the final temperature? Again, we have to list the known quantities and plan the problem. So the given information is the initial pressure, P1 equal P, and the final pressure is 2 times, that means 2P. The initial temperature T1 27 adding 20 273, that's equal 300 Kelvin. What we want to find, we want to find the final temperature T2. Now we have to plump our, we have to put the equation P1 divided by T1 equal P2 divided by T2 and rearrange the equation to find T2. And we have to substitute the known information and calculate our result. It's 600 Kelvin. Now we have to think about our result. So the initial temperature 300, the final temperature is 600. That means the temperature increases the 2 times as the volume increases 2 times as well, or the pressure increases 2 times as well. To remember how this works, so I can give you some idea. If you like it, you can remember the parameter we took and the relationship between all of them. So we have the pressure, the temperature, and the volume, and we can make a phrases like a public television. So a public television, PTV, pressure, temperature, and volume. To remember which constants go with which law, again, you can put some phrases, easy phrases to remember each one. So for the Boyle's law, temperature is constant. You can pass in the initial letter from each word, so B, L, T. Boyle's law, temperature is constant. For the Carnot law, pressure is constant, so we can just make a simple phrase like a cheese pizza. So CP, that means Carnot law, pressure is constant. And that for the Gay-Lussac's law, volume is constant, and we can put a phrase like green veggies. Combine gas law. It is a law that combines the previous law into one. So we can combine the 3 laws to create one law. B1 V1 divided by T1 equal P2 V2 divided by T2. The equation is found in table 2. Note that all temperature must be in Kelvin. So units used to describe gas sample. Volume, the unit of the volume, liter or milliliter, and 1 liter equal 1000 milliliter if we want to convert between the units. For the temperature, Kelvin only. For the pressure, atmosphere, kilopascal. And the 1 atmosphere equal 101.3 kilopascal, or 1 atmosphere equals 760 millimeter mercury, and 1 atmosphere equal 760 torr. Avogadro's law. Avogadro's law equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. So it gave the relationship between the volume and the number of moles. So V1 divided by V2 equal N1 divided by N2. And 1 mole of any gas takes up a volume of 22.4 liters at standard temperature and pressure. A balloon has been filled to a volume of 1.90 liters with 0.0920 mole of helium gas. If 0.021 mole of additional helium is added, to the balloon while the temperature and the pressure are held constant. What is the new volume of the balloon? So again, we have to list the known quantities and plan the problem. So the given information we already know. Initial volume equal 1.9 liter. The initial number of moles equal 0.092 mole. And the final number of moles equal the initial one to the additional helium. So 0.0920 add 0.021 equal 0.113 mole. What we want to find, we have to find the final volume. Then we have to put the equation of the Girosak law and rearrange it to find the V2. V2 equal V1 times the initial number of moles divided by the N. And then V2 equal, we have to substitute it the quantities we have, and we have to cancel the units and calculate our results. And finally, we have to think about our results. So the initial volume 1.9 and the final volume 2.3, that means the volume increase and the number of amounts increase as well. Idle gases. Idle gases whose behavior can be predicted by the kinetic molecular theory, are called idle or perfect gases. No gases are truly idle because no gas totally obeys all the gas laws. An idle gas is an imaginary gas that is perfect and does follow everything perfectly. Idle gas does not condense to a liquid at low temperature, and an idle gas does not have forces of attraction or repulsion between particles. An idle gas is composed of particles that have no volume. So it is not a real gas. It's just we can imagine there is a gas with these properties. So the original idle gas law uses the formula BV equal nRT, where R is the idle gas law constant. The value of R were found out to be listed in the table below. It's even 1.0082 if we use the units liter atmosphere, and it will be 62.36 if we use the units liter torr, and 8.3 cubic meter Pascal, and 8.3 again if it is joule per mole or 2 calorie per mole. The relationship between the density of idle gases. So BV equal nRT, the equation of the idle gas, and we know that the number of mole equal the mass divided by the molar mass, and therefore BV equal M, the mass, divided by the molar mass time RT. and then the density equal M divided by V, and then the final equation will be Pm divided by RT. The pressure, the molar mass, the ideal gas constant, and the temperature. And we can take this example like a homework, and there are extra example in the PDF version of the lecture. So I want you to solve this problem and send the solution to me, please. We have two more laws. It's the Graham law, particle of low molar mass travel faster than heavier particles. For example, hydrogen fuses 4 times faster than the oxygen. So the molar mass of the hydrogen is just 1. So the molar mass travel faster than the oxygen, because the oxygen, the molar mass is 32. So it's much bigger than the hydrogen. And we have the Dalton's law of partial pressure. In a mixture of gases, each gas exerts a certain pressure as if it were alone. So if we have a container and the container consists of 2 or 3 gases, each gas will behave like it is alone in the container and there is no another gas with it. The pressure of each one of these gases is called the partial pressure, and the total pressure of a mixture of gases is the addition of all of the partial pressure. So the total pressure equal the pressure of gas A, or the pressure of gas B, or the pressure of gas C. Finally, we will give some extra information about the ideal gas and the difference between the ideal gas and the real gas in the next lecture.